This is the first time actually we're going to be dealing with continuous functions. All the stats that we did was discrete. So what happens when your function is continuous, which means it can have any value in it? How much milk you're getting? Or an example, let's say you're a mechanical engineer. You're drilling a hole in this block for the engine of your car. You have the block here. You can drill a hole for the piston to go through it. Well, that hole is supposed to be a certain width or a certain diameter. Well, when you drill, it's not going to be exactly that number. It could be anywhere in between. Let's say it's supposed to be 3 inches from end to end. It could be 3.01, 3.001, 3.5. That's not good. If it's 3.5, we've got a problem. But the value, that width, it's not going to be 3 inches. It could be anywhere between, let's say, 3.1 to 2.95 to 3.01. Could be any number in between. So that's a continuous function. So if you graph your function for that distance, most of them is going to be around the 3, but it might look something like this, where you could have any number between. For example, let's say this is 2.95 and down here 3.1, the width of it. Most of them should be around the 3 inches. We're hoping our machine, most of them are 3 inches right in the middle, because otherwise, if the value changes by a lot, we got a problem. We're going to throw half these in the trash or remelt them and use them again. So now we're dealing with continuous function. When you have continuous function, first, if you want to test to see if your function is a valid function, remember for probability distribution, what was the condition you test to see if the table I'm giving you is a valid table or not? When we did discrete values, and I gave you numbers like these, x and the probability of x. And we said when x is 1 is 0.5, when x is 2 is 0.3, when x is 3 is 0.4, when x is 4 was 0.2. I said, is this a valid probability distribution function? And there were 2 conditions you have to satisfy to make sure that is a valid probability distribution function. One of them is the probability of any event has to be between 0 and 1. And the other condition is what? When you add all these probability, the sum has to be 1. How do you validate a continuous random variable? How do you know if the density function, we call that, by the way, instead of probability, we call it density function. Let's say I'm giving you a density function. How do we know that density function is a valid function? Well, you can do that by adding, in summation in calculus becomes what? Integration. If you integrate from negative infinity to infinity of all the f of x, d sub x, the answer should be 1. That's how you validate if your function is a valid continuous probability density function. So I'll put them on the next page here. I'll throw this one. This just to refresh your memory. A continuous random variable with probability density function, probability, not density function. We call it f of x is valid, is a valid density function if what? if you integrate that from negative infinity to infinity of f of x dx, and that integral ends up being 1, you have a valid density function. And if you want to find, I'll just give you some equation. If you want to find the probability, assuming this is a valid density function, now you want to find the chance of the value landing between A and B. What's the probability that x will be between A and B? This will be, it doesn't matter if you include these numbers or not. Why? When you integrate, what's the integral of a point? 0, right? So that's the same as the question, the probability of x is greater than or equal to A less than B, which is the same answer as the probability of x is bigger than A less than or equal to B, which is the same as the probability of x is greater than or equal to A less than or equal to B. This will give me the same answer because a single point does not have an area. It's the integral from A to B of f of x dx. And when you're integrating, if you remember from calc, actually, I don't want you to think it's normal distribution. It doesn't have to be normal distribution. My function could look like this. I don't want it to look like a normal shape. It could look like this. That's my density function. Could be any shape. When you want to find the area between A and B. This is A and B. You integrate that. If you include it at A or not, this line does not have any area because the width is 0. Remember, the integral is the area under that. So when you integrate from A to B, you're finding that area. So what if you include the line or don't include the line? That doesn't change your answer. That's why it could be less than, greater than, one of them equal, or both equal. Your answer doesn't change. If you're looking for the probability of x less than A, less than or less than or equal to A, could be the same. That will be the integral from where to where? From negative infinity to A of f of x dx. And if you're looking for the probability of x is greater than A, that will be the integral from where? From A to infinity f of x dx. So we can we validate if the function is a valid function or not. We can find the probability of landing between two numbers, or bigger than a number or less than a number. Okay, here is an example. Again, let's go back to that hole there. We want to drill a hole there in a piece of metal. And we're going to put a shaft through that hole. Here's the shaft. It's going to slide through that hole. The distance between, a different color, between the shaft and the hole is called the clearance. That's the clearance of, and the value of that depends. So we define the clearance for that function to be, x is the clearance here, is equal to what? 1.25, let's say millimeters, 1 minus x to the 4th. And this is good for x between 0 and 1, and 0 otherwise. Mr. R. Zero is otherwise. So the clearance is the distance from the edge of that to the shaft. How much clearance do you have? And somebody calculate the equation for us. If we graph that function, 1 minus x to the fourth, x to the fourth the same as x squared, the graph of it, with the minus in the front that says concave or it's open downward. So the graph of that, if you have a graphing calculator and you graph that, when x is 0 has a height of 1.25. When x is 1, that will go to a 0. My first question is f of x a valid probability density function? There we go. Is it? Well, let's see. To be a valid density function, if I integrate that from negative infinity to infinity, f of x dx, it has to equal to 1. Well, let's integrate that one. These, by the way, are not in your book, not in the notes, so it'll be on my notes only, unless you go and start looking for a continuous function. So if we integrate this as from 0 to 1, 1.25, 1 minus x to the fourth dx. Does that equal to 1? If the answer is yes, we have a valid density function. We can factor the 1.25 out, if you remember your integration. Integration, not derivative. What is the integral of 1? X, right? What's the integral of x to the fourth? From 0 to 1. So you plug in 1 in it, then you plug in 0 and you subtract them. When x is 1, it's 1.25 times 1 minus 1/5 minus 1.25 when x is 0, 0 minus 0. That's 4 over 5, 0.8. What's 1.25 times 0.8? Is it a 1? Then that is a valid density function. That's the first question. Okay. Find the probability that the clearance will be larger than, this marker is making noise, I'm sure it's aggravating people listening to the video, larger than 0.7. So in this case, that will be what? Larger than 0.7. The integral from where to where? 0.7 to 1, 1.25, 1 minus x to the fourth dx. Let me just pick a different marker, different color one. See if less noises. Yes,
So why are we doing 0.7 to 1?
because this function is valid to 1.
Gotcha.
Notice, Scott, this function is only good from 0 to 1. So from 0.7 to 1, after that 0, so I'm now, it's supposed to be 0.7 to infinity, but since after 1 has a value of 0, you know,
Understood.
yep, so we don't have to do it. So again, this will be 1.25 x minus x to the 5th over 5, and plug in the limits 0.7 and 1. Minus 1.25, 0.7 minus 0.7 to the 5th over 5. Huh?
0.167.
Final answer? 0.167. So the probability that the clearance for that will be bigger than 0.7, we have 16.7% chance that the hole we drilled there in that sheet of metal there and the shaft will have a clearance bigger than 0.7 millimeters. Okay. That's the first part. Second part is if you want to find the mean and the standard deviation for a continuous function. When you have a binomial, remember binomial? What was the mean equal to? Isn't that the summation of what? Oh, not binomial. When you have a probability distribution table, binomial was n times p. When you have probability distribution table, I'm not talking about continuous here. Probability distribution table. Yep. The mean was the sum of x times piece of x. And what was the standard deviation for that? Of x squared times piece of x minus mu squared. Okay. When you have a continuous probability density function, f of x, then to calculate the mean, you want to take a wild guess on it? What's the mean going to be? Think of calculus. Summation becomes what? Integration of x times what? F of x we use for density function, right? And the standard deviation is going to be the square root of what? The integral from negative infinity to infinity of x squared f of x dx minus what? Mu squared. It's the same thing.
Is the minus u squared on...
Under the square root still. Is that what you're asking?
Yeah.
Yes. Just like this one. So let's go back to the same example we just did. the clearance for the shaft and that hole there. We'll test it on this. We said the clearance was what? F of x equals 1.25, 1 minus x to the fourth, was it? And 0 otherwise. For x is bigger than 0 and less than or equal to 1. Doesn't matter if you put equal or not. 0 otherwise. So what's the average clearance based on that? That's the equation that describes the holes that we dug in that sheet of metal there, the clearance between the shaft and the hole. So what is our average clearance? Well, based on that, it's the integral from where to where? From 0 to 1, x times f of x. What's f of x? 125 times 1 minus x to the fourth dx.
Is it 125 or 1.25?
120, was it 125? That was 125, right? Oh, 1.25, I'm sorry. Yeah, 1.25, yeah. It was 1.25 initially when we did it, right? The first time, yeah. So I can factor the 1.25 out. X minus x to the fifth dx. So it's 1.25. Let's integrate that. That's x squared over 2 minus x to the 6 over 6.
Wouldn't it be x to the fifth over 5?
X times x to the fourth,
Oh.
x to the fifth, right? So I multiply this x by this x by that. First distribute that. Now I'm integrating. So when x is 1, we have 1.25. 1 half minus 1/6. Minus when x is 0, that's a 0. That's 3 over 6, that's 2 over 6, 1 out of 3. It's 1.25 divided by 3, I think the answer. 0.417 millimeters. So we expect the clearance between the shaft and the hole an average of 0.417 millimeters. What is the standard deviation? To get the standard deviation, what was the equation I just gave you?
Square root of the integral x squared fx dx minus.
Yep, the integral from negative infinity to infinity, x squared f of x dx minus mu squared. The integral from 0 to 1, x squared times 1.25, 1 minus x to the fourth, dx minus, I just calculated my mean, 4.17. The integral from 0 to 1, x squared minus x to the 6 dx minus 0.417 squared. I'm going to call this sigma squared because I just don't want to write the square root till the end. I want to keep dragging that line over it. So if we square the square root, you end up with that number. So that would be what? 1.25 x to the third over 3 minus x to the 7 over 7 from 0 to 1 minus 0.417 squared. 1.25 times 1/3 minus 1/7. 1.25 times 1 divided by 3 minus 1 divided by 7, 0.238 minus 0.417 squared, that's sigma squared. And that's 0.0642, which means sigma will be the square root of that number. .253 millimeters. Did we integrate right? Seems that number high, huh?
I plugged it in the calculator and got 0.203.
For which one? The final answer?
Yeah.
Because that seems like a little bit high. Let me just see. The square root of that number. This is good, actually. 0.0645. Square root 0.0642. Oh, it is 0.253. It just seems like, I don't know, for some reason, that's 64 something times something squared. 0.25 times 0.25 is 0.064. Okay. Let's try another example. I might have a box of tissue here, maybe. There used to be one here. Nope, it's gone. You can take the whole roll there. Let's take another one here. Ooh. This example, we have radioactive mass. Radioactive mass.
Number 5 is the same as number
Emits
2.
uh-oh, alpha particles. That's not good. Alpha particles from time to time. And somebody calculated the time between emission in seconds. The density function for that, somebody calculated that, we don't care. I'm going to actually do something to it. Some constant, e to the negative 0.1x, for x is greater than 0 and 0 otherwise. I changed the problem completely. First question I have for you, what value of k will make the function, the density function, a valid function? What can we use that will make it a valid function? Remember, for this to be a valid function, there's a condition we stated early. What was the condition?
The integral of it needs
The integral from where? Negative infinity to infinity of f of x dx has to be what? 1. Well, let's go through it, integrate that, and see what k will have to be to make it a valid density function. Actually, when I make a test, that's what I do. A lot of times I make problems like these, and I don't know what k is. So instead of getting the wrong question, I says, can you find what k will make this a valid density function? So you have to do the work, not even me. I put something up, and once you figure what k is, I'll ask the rest of the questions. So how would I find k? I'll integrate that. This is from 0 to infinity. K e to the negative 0.1 x dx has to equal to 1. I can take the k outside the integral. That's a constant. And if you remember, to integrate e to the negative alpha x, whatever, this will be k over negative 0.1 e to the negative 0.1 x. In case you forgot the rule I'm using, e to the alpha t dt, the integral of that, it's 1 over alpha e to the alpha t. And you want to go from 0 to infinity, and you want that to be 1. Good. This is negative 10k. If you do the math, k over 0.1 is negative 10k. E to the negative 0.1 x from 0 to infinity equals to 1. Now let's plug in the limits. E to the negative infinity minus e to the 0. E to the negative infinity, that's a 0. E to the 0, that's a 1. So 0 minus a 1, that's a negative 1. So 10k equals 1. K will have to be 1/10 or 0.1. So for that to be a valid density function, you want k to be 0.1. Any other number, your function is not a valid density function. Okay. Let me take you back to discrete math. Find the median. Median. Remember the median of that function? When we did the median of a set of numbers, what was the median? The value in the middle. That has 50% of the values to the left of it, 50% to the right of it. Right? So I'm looking for is what value here If I integrate my function from 0 to x of 0.1 e to the negative 0.1 x dx, I want that to equal 0.5. I want it to equal to the middle number, 50 percentile. That's what the median is. The value that will take the list and cut it into 50% to the left, 50% to the right. Let's factor that 0.1 outside. And if you divide, well, I was about to divide and do the whole thing in one step, but I can wait. What's the rush? If I divide by 0.1, I have the integral from 0 to x, e to the negative 0.1 x dx is equal to what, 5? When you divide both sides by 0.1. Integrate that negative, or 1 over negative 0.1 e to the negative 0.1 x as x goes from 0 to x. That's a negative 10. That's a negative 10. If you divide both sides by negative 10, what's 5 over negative 10? Negative 0.5. Now plug in the limit. E to the negative 0.1 x minus e to the 0 equals negative 0.5. E to the 0 is 1. One minus 0.5, which is 0.5. And to cancel the e, what do? Natural log of both sides. Point 1 x equals natural log of 0.5. What's x? Where's my calculator here? Notice the math starts to get a little bit more challenging. ln of 0.5 divided by 0.1 negative 6.93. Oh, you know what? I missed this minus sign here, right? That'll make it a plus. Somehow I dropped the minus sign. So it's 6.93 milliseconds or seconds, whatever the units were, I forgot. Emits in seconds, it said. It's about every 7 seconds it emits some of that radioactive material. That's the median. Remember, this function, the probability density function, is the percentage, really. It's probability. So if I said to you, what is, pick a number between 0 to 100, not 50. What is the 75 percentile? I can write 75 percentile instead of percentage. Write percentile. What is the 75 percentile? Again, you want that number equals 0.75. You can find any number that'll give me the 75. When you say the 75 percentile, that means this number, if you hit that number, that's top 75%. Again, if you factor the 0.1 out, that's divide by that. This is 1 over negative 0.1 e to the negative 0.1 x. That's a negative 10.
Professor,
Yes,
why did the 0.75 become 7.5?
because I factor the 0.1 out and I divide both sides by 0.1. Try to cheat. Took one step out, you know. I took the 0.1 out first and I divided both sides by 0.1. And just like what I did, the same thing here, that's a negative 10. If you do 1 over negative 0.1 is negative 10. I said divide both sides by negative 10, end up with that. So I cheated a couple of steps there.
Why didn't you just let the integration get rid of those constants?
Which constant, Dan?
When you integrate, you have 0.1, then you divide 0.1 by 0.1 when you integrate. So that just comes out to 1, so you don't even need to...
Yeah, you can divide by 0.1 both sides to make that a 7.5. Is that what you said? Yeah, you could, yep. You could, instead of taking it out and dividing, so why not just divide by 0.1 here? It's an equation. I could have done that. It's not as fun as the other way. Other way is 2 steps. You know, it makes it more like, wow, we did 2 steps instead of 1. So now we plug in the limits. E to the negative 0.1x minus e to the 0, which is a 1. That's a negative 1. Move it to the side, becomes a plus 1. Take the natural log of both sides again. Negative 0.1x equals the natural log of 0.25. Which is negative 1.386. X will be positive 13.86 seconds. So that's how we calculate actually the mean, the standard deviation, the probability, the median with continuous function. We're not done. That's just the beginning of it. Now, what happens if you have a joint density function? We're going to deal with that next time. And what that means, just something to think about. Here's what I'm thinking about. That's for the next video. Start talking about, let's say I have 5 quarters in my hand. Now I'm going to record how many times it lands on head on the first time. Is it possible to have 0 heads on the first time? 1, 2, 3, 4, or 5. But now, the second time. Now you take all the ones that didn't land on head and flip them again. Well, wait a minute. It's possible to have what? 0, 1, 2, 3, 4, 5. See where I'm going with that? So now, if the first time 3 of them landed on head, 3 of them, then the second time, this will never be 3. So this will be what? For this will be a 0, 0, 0. Why? Because if 3 of them landed on head on the first time, that means you're only going to flip how many? 2. Your outcome is 0, 1, or 2 the second time. If on the first try 2 of them landed on head, only 2, that means you're going to flip how many more? 3. So this is 0, 0. Can't happen here. Can't have 4 of them if the first time 2, because I'm only taking the ones that landed on tail and flip them again. If one of them lands on head, only 1, then I got how many of them to flip for the second time? 4. So this can't be. I can't have 4 heads. If I have 4 of them landed on head the first time, how many I have to flip? Once. It's either 0 or 1. I should have went higher with that. That's the 0. I should have went higher. Now I'm screwed with 0, 0. But that's the process I'm going with it. You know, that's a joint density function. You could do something. Or think about a different approach. You have a house insurance, you have a car insurance. Some people, if you have a house insurance with one company, you tend to have car insurance with the same company. Some people have only house insurance with one company, car insurance with a different company. So you can look at that, the joint. If somebody has a house insurance with this company or a car insurance with this company, what's the chance they'll have a house? What's the chance they'll have a car insurance with the same company? So that's where we're going to go with that. We start dealing with double integrations. We'll wait on that till next time, because we have something